Good morning, everybody. I see it was a good social. My name is Emile Aben. I work for the RIPE NCC. I do research and development. So that's making ideas we have internal to the RIPE NCC and also from our community into a reality. So it's prototyping of these things. So if you have interesting research ideas, please come approach us. And yesterday I already had some nice inspiration from some people here, so thanks for that already. So what I'm going to talk about today is a measurement study we're doing with RIPE Atlas on keeping local traffic local. Yeah, okay, yes. So keeping local traffic local, that's what you hear quite often in the context of creating IXPs. But let's for a minute go back to why we actually want to do this. And first thing here is cost. And there was a lightning talk yesterday talking about energy costs, for instance, but there's all kinds of monetary costs for if you have a packet that has to travel within your country, why would you send it to big place, to faraway places? That costs infrastructure, that's probably transit costs versus keeping stuff local, which could be peering. So generally, keeping it local keeps your costs low. The other one is service quality. If you have multiple parties involved in bringing your packet from A to B in the same country or in the same city even, that's multiple parties, multiple handoff points where things can go wrong. So, and it adds latency, of course. So if you keep stuff local, that means your service quality is likely improving, which means happy users. And we all want users as happy as she is. The other point is security, and that maybe was maybe less relevant before Snowden, but with Snowden, people start to be very cautious about things going through certain countries where surveillance takes place. So that's another reason. So that's the first part. The second part is RIPE Atlas. So who here doesn't know RIPE Atlas? Okay, so I'll keep that very brief. So we have quite a nice coverage of measurement points. So it's a measurement project for the community, by the community. It's these little devices, and this is a map of where they are deployed. So if you look all the way up north there, there's even one in Svalbard, in almost the North Pole. So each of these dots is actually something like this, and this is the actual probe connected in Svalbard. So these are actual devices that you can use to measure the internet and that we use to measure the internet. A little bit more about nice big numbers. And Vesna talked about that yesterday a little bit on the mic already. 270 of these, it's 1U devices that are like very stable and do more measurements. We're in 179 countries, 91% of all countries, 6% of IPv4 networks and 9% of IPv6 networks have at least one RIPE Atlas probe deployed in them. So that's, I think that's pretty impressive numbers, but we can always do better. So if we combine these two things, keeping local traffic local and RIPE Atlas, can we actually combine them? So, and this was like a research idea, and the short question is yes, or the short answer is yes, we can actually do this. But there are many challenges left that we are currently exploring. There's some in appendix, but there's all kinds of things with geolocation accuracy, how representative is a single probe of a larger network. It's all these types of questions that we're actively looking into. That said, the measurement project that we have is called IXP Country JEDI. So what we're actually doing is looking at questions like, are the path between two ASs that have a local presence in a country, the path between them, do they stay in the country? Or do we see them going outside of the country and going back again? Do we see a difference between IPv4 and IPv6? Do we see path going through the local IXP or not? And for network operators, are there networks in my country that I could peer with to improve reachability or change configuration to improve things, to make things better? And as I already said, this is an experimental tool. It's a prototype, and it heavily depends on the measurement points. And I'll get back to that a little later. Of course, feature requests are welcome, and we're very open to that. So let's focus on Montenegro for a moment. If you look, I don't know if the map is very well visible in the room, but if you look at the map, all of the probes are in Podgorica. I hope I got the pronunciation right. That's what we're able to measure currently. But there's other places. Well, we're in Budva here. Nikšić, I've been told, is the second largest city. And there's rural areas. How is the internet here different in rural areas than in cities? It's all these types of questions that we can only look for answers if we actually have measurement devices deployed there. So that's sort of like a geographic look onto how you could actually look at these, at the distribution of these little devices. Another look is where are your end users actually? And so we have a research intern, Petros Gikis from Greece, who's actually looked into this, and what he did was take market share estimates, and that's our colleagues from APNIC and other RAR provide these estimates, and we believe them to be roughly correct. And see, with these estimates, you know which networks have the largest number of end users in a country. And then we look at, do we actually have RIPE Atlas probes deployed in them? And for Montenegro specifically, we didn't see them in these networks. We actually had one in Telenor, but we couldn't get any useful measurements out of that device, so we didn't count it. So if you want to see this for if you're not from Montenegro, if you want to see this for your own country, in the first URL, replace the ME there with your country code, and you can actually see what it looks like for your country. And so the open question is, can we get these probes deployed in these networks? Can you help us out in doing that? So at the service desk, I have two of my lovely colleagues who have the same interface, and if you approach them in the break or later during the day, they will try to help and see if you have some specific networks that are in this list, or if you have places where you can put these probes that are not Podgorica. They will be very happy, and we will be very happy, and you'll be helping out our measurements efforts in if you could deploy the probes there. We have a platform called RIPE Labs where we put out articles, blog posts about our research activities, and about this specific interface. There's a nice article at the bottom link in this on this slide. So now we covered the probe coverage. So the tool itself, the tool to measure between these probes, between the probes in a specific network, or in a specific country. This is the URL there, so it's on GitHub. If you want to do stuff with it, you can run it locally. And Daniela, for instance, yesterday, I was really happy to see that he's been using it, and we've been using it to fix peering in the Middle East. So I'm really happy that this is it's so open, so anybody could use this change it to their specific situation. And there's also a RIPE Labs article about it, which is the second link here. So the tool itself, let's dig into the nitty-gritty details of what it's actually doing. So we're doing a traceroute mesh. So traceroute, so you detect the path between point A and point B, where A and B both are RIPE Atlas probes. So I have a RIPE Atlas probe in one network in a country, a RIPE Atlas probe in another network in a country. We look at the path, and for each hop we detect, is it an IXP hop? So do we see the peering LAN of an IXP there? And the other one is, can we geolocate the IP address of the hop? And for the IXPs, we use PeeringDB. It's like the open, it's an open database, and we like open and transparent. So we are really encouraging people to put peering LANs and other information that's useful in PeeringDB, because that helps other people see your networks. And actually for the local IXP, MIXP, yesterday I sat with Alexandra from MIXP, so we actually fixed the IXP, the MIXP entry for PeeringDB, so we can automatically detect it now. So we're really making progress there. So we do this mesh. We do maximum 2 probes per autonomous system. So because we have very large networks like Deutsche Telekom that have hundreds of probes, so you would not want that network to dominate the measurements that you're doing. We do this on public probes with good geolocation. And the geolocation of the intermediate hops we do with OpenIPMap, which is a tool we built ourselves, which is crowdsourcing of internet infrastructure IP addresses. So the IP addresses of a router, how do you translate that to a city is what we're currently using. Because if you use an open database like MaxMind, that gives you all kinds of weird and interesting results that are definitely not true. What we do with all this measurement data, so these paths, is we visualize it as a map, as a matrix, and as a graph. And I'm going to show the examples. So why are we doing this? There's a lot of stakeholders here that we're trying to target. For a country, it's regulators, politicians, cybersecurity. So how much does stay in a country, and if they don't stay in a country, where do they go? Operators, it's about routing and traffic optimization. It's showing where potential stuff can be improved. IPv6 advocates, it's comparing IPv4, IPv6. The IXP operators is to actually show the benefit of an IXP and help show the benefit of an IXP in keeping local traffic local. For the RIPE Atlas community, we want the whole community of people using this measurement network to have the best measurement network possible, so that's why we want to deploy probes in as many places as possible. And the tool is also a use case for improving the data quality of infrastructure geolocation, IP infrastructure geolocation. So let's drill down to the local country here, Montenegro. What we do is we run this tool every month for all the countries where we have enough probes. So on this URL, replace ME with your local country if you want to see all these visualizations for your local country. The one that's on the screen here is the ASs, the networks that we detect in Montenegro when doing this mesh of measurements. So I don't know if there's 3 white points, which are the 3 networks that we have currently covered in Montenegro, and all the points in between are the autonomous systems, the networks that provide the interconnection there. So this is a matrix visualization of the same data. What you see here is the rows are the sources. So these are individual RIPE Atlas probes. The destinations are the columns. And so each cell is a source-destination combination. And we color them based on certain properties of the path. And we actually use two properties. One is, do we see a local IXP? And the other property is, do we see the path go out of country and back for 2 points in Montenegro? So it's 2 times 2, it's 4 combinations. So red means it goes out of country and we didn't see an IXP, didn't see a local IXP. And you actually see 2 examples of that. Green would mean it's not visible on this one, but that means there's a local IXP detected and we don't see the path go out of country. So that's, from an IXP perspective, you want to see a lot of green here. The orange is we didn't detect an IXP, we also didn't detect a path going out of country. So it could be a direct interconnect or a local transit network involved maybe. We are doing work to actually distinguish these. But this was the situation last week is when this visualization was there. Actually, if you go to the website, this is an interactive tool. Again, this is a prototype. We could have our inferences wrong, so what I find really important is being able to actually verify if the data underneath this is good. So if you click on one of these in the interactual visualization, you'll actually see the traceroute path involved. And well, it's a bit small here, but you can actually see that we detected 1 hop in Frankfurt, in Germany. But I knew there was a local IXP here, so I was wondering, we should be able to detect that. And the problem here in detecting it was that the peering DB entry wasn't there. So after the fix that Alexandra did yesterday, this is what it looks like now. So we can actually see this green thing here, this green dot is a mix keeping local traffic local. So, and that's why it's important to keep your peering DB entries up to date. And you can actually also see it in the AS graph visualization. And hopefully if we have more of the eyeball networks, the end user networks, this would extend into a greener matrix, which would show mix keeping local traffic local. So and this is the geographic view, the 2 red cells here, and I'm not sure if you can see the lines, but there are lines going to Amsterdam, Frankfurt, Budapest, Belgrade for the 2 the red cells, the ones that send the traffic to far away places to come back. So, and actually, if you look back, these were all probes in Podgorica. So this is Podgorica to Podgorica traffic going very far and coming back again. 5 minutes. Okay, so what we can also do with the tool is measure pairs of countries. So I created a snapshot of this. Here's the URL. So what I did with this was measure Montenegro and its neighbors. And so this is Montenegro, Albania, and it kind of looks like Daniela's presentation yesterday. It goes all across the place. Montenegro, Bosnia-Herzegovina goes all across the place. Montenegro, Serbia goes all across the place. And this is not very strange, or you see this all over the world, that as soon as you look at neighboring countries, that it's not neighboring countries directly, you don't see direct path, stuff goes abroad very often. Yeah?
Oh boy.
So, next one, Montenegro, Croatia. But if you just compare this to, so it's not a strange thing, and this is a potential for keeping local traffic local, keeping local stuff local to the region, where you look at your neighbor countries and see what things you can do with your neighbor countries. Because it's very different from if you just take a vehicle. So this was the trip that I did last Sunday from Dubrovnik to here, which is very, I mean, it takes 2 hours, so it's not milliseconds like internet packets, but it's more efficient in direct distances. So why do these paths actually, the internet path actually look like this? And this is just what I think, and I'd be happy to hear if this is correct or not. So internet routing isn't vehicle routing. We're pretty clear about that. What I think is happening is that if people do BGP optimizations, it's mostly based on the high cost, so the high volume traffic flows. So operators typically optimize for the Googles, the Facebooks, the Amazons, the Microsofts, and these networks also optimize for network operators. So what's left is a very long tail of potentially high value but low volume end user traffic. Could be like real-time traffic, and then the latency and locality of these networks is accounted for in BGP a little bit in AS path length, but that's about it. So what you really have to do is to get to peer with local players to shorten your AS path, add an IXP or do direct interconnects, and if you don't, then stuff goes through transits, and they just connect where they interconnect, right? So let me finish with potential actions that people can take. You can use this tool to find suboptimal routing. You can go to the visualizations and figure out where your AS is in this system. If you have a probe in the network, find other people that have probes and have tea together and try to see if there's things that you can fix. Well, we know there's some accuracy issues with these tools. So, for instance, if your AS is not on the graph, please go and you want to have this data about your network. Please go talk to the people that have these probes. Come talk to me, come talk to other people here. I know Vesna has probes with her, but other RIPE NCC staff can help you with this. If you have a probe and you move, it's also nice if you update the probe's location, because then we make this tool most accurate. Then again, this is open software, it's free, just so use it, abuse it any way you want. And on the infrastructure, if you have ideas on how to improve that or want to contribute there, we're also very open to that. So that ends my presentation. Okay, perfect. I see a stop sign, so I'm just going to ask for questions. Any questions?
Hi. Sorry. Dušan Vučković, University of Niš, Serbia. Please tell me, is there some general plan for the replacement of the older generation probes, which showed a little bit unreliable lately? Because you need to bear in mind that as Atlas ambassadors from the non-EU countries, we are basically smuggling probes in and out of the country every time there's a conference. So any plan for instatement of maybe virtual appliances or something, that would be very helpful.
There's a plan for a virtual appliance that's being worked on. Also, the older probes, we know there are issues, so for the smuggling or having to smuggle, I don't have a good solution for that except for fixing international borders, but that's not in my control. So
There's no borders.
yes, see, but then it becomes physical and it has borders again. So yeah, that is an issue. I can only acknowledge that, and we're trying to we try to come to local meetings like this, bring probes to alleviate that a bit.
What about virtual appliance?
Yes, that's okay. I heard virtual appliance twice. I will surely report back that was a
interest in it.
That there's interest in that, yes. Yeah.
So,
Thank you, Emile. My name is Michael Ogeya. I'm an independent consultant. And I do have a right probe, by the way, so I'm speaking on as a host. I actually have many suggestions and comments. The first one is about the IXP Country Jedi. I might be the only person in here that's not a technical person, and I really love the IXP Country Jedi concept. I have no idea how to implement it. I don't know how to, sorry if I'm losing respect, but I have no idea. I don't really know how to download it and use it. I've tried. It's really difficult. So a concern that or like a suggestion maybe would be, I thought that when I looked for it, it would, some kind of visualization would come up on the website that I could then kind of play around with. And I actually think that would be a really good way to engage with non-technical stakeholders that want to learn about how traffic is moving, especially people within, actually within any stakeholder group. So that's one suggestion for that. Then with the probes, I had a comment that it was a thread that I had initiated a couple days ago about credits, because, for instance, I had a lot of credits that I didn't even know what to do with, and it makes me think that a lot of people, I know this because I've been talking to people, there are those who want credits who can't get them. Now I've set it up in such a way that I transfer my credits every time it hits 1 million to a few different people who requested them, but it makes me wonder if there's 10,000 probes, how many of those people that have those probes are actually using those measurement credits, and how many people might be able to use those credits that are going unused. Now, I know that Robert from RIPE NCC got back to me and told me about standing order, which is the transfer process. But basically, I don't know, doing something that to help enable those that need those credits that can't get them. Yeah. I think that's another way that it could improve the program.
Yes. So to get back to the second point first.
Sure.
For credits, if you have a need for credits, you can always come talk with us, and we're very happy if there's a good reason for it to extend any limits. These limits are there to protect the system itself. So without, if too much load on the system would have negative consequences to all users. So that's why these things are in place. And so we have means of giving people credits that need them. Researchers typically want a lot of credits, or if people want certain measurements started that are of the general benefit, we typically start them. So that's on the credits part. And the other one was about
Country Jedi.
like what the tool actually is, and it's a bit. It's actually two things right now. It's a piece of software that you can actually run, and we run this piece of software monthly for all the countries. So if I go back, and oh no, now there is a URL here. Yes, this here replaced that last part, and we're actively working on making it much nicer, because you're not the first one making this suggestion. It can definitely use some better interfacing.
Another idea, and forgive me for taking so much time, but another idea might be also to, just for some of us, to even just have an upload of various screenshots, just screenshots of the Jedi, of the Country Jedi for major IXP routes, whether it be for Europe or Asia or wherever. I mean, wherever you think, or in your experience, people are curious about seeing that network traffic. Even if we could even just take a download just one screenshot to include in a presentation or something, that would be helpful for me. But
okay, yeah.
Thank you.
Okay.
Thank you.
Hi, I'm. Okay, hi, I'm Daniel Kahnberg. I'd like to comment on some of the things that have been said. Thank you for the very good suggestions, by the way. I think if you want to sort of strategically improve the user interface of some of the research we're doing, I think you'll have to find some allies. I suggest that you find some allies and use the right process to actually forcefully call out this requirement. I think it would require a serious allocation of resources inside the NCC to actually make this happen in a structural way. I feel a bit of pity with Emile here, who's a researcher and shows you research tools, being sort of asked to have a good user interface. That's not his job. We actually have people whose job it is, and you see the result in RipeStat. But if you want this stuff to develop more into a nice UI, regular screenshots and things like that, I think it shouldn't be Emile's job. And if there's a genuine sort of clearly voiced requirement for that by many people, I think the RIPE NCC could do that strategically rather than tactically. So here's a suggestion. The other is my usual soapbox, about the software probes. I think we have to realize that the RIPE Atlas is unique in the sense that the probe population of those 10,000 is relatively homogeneous and their performance is predictable. We have 3 different versions, but still the performance of these things is predictable. So if you do measurements, you can at least quantify the influence of the environment in which the measurements run. As soon as you virtualize that, you lose it. That's one reason why we haven't done it initially. And if we're going to, and we've been asked this for a long time, but please realize that what you measure then, if you use an appliance, is something totally different than what you measure with a hardware device. So we would have to sort of categorize those measurements as being different. Yeah. The other is, as soon as you do things like that, there's a reputation risk for the RIPE NCC, because you run this stuff on much more powerful hardware and on things that also run other things. And if those things get hacked, we get blamed. Yeah. So just realize that as well. So it's not. Many people come to me and say, "Oh, it's just easy. Just make us a whatever image of your preferred virtual environment, and it will all be fine." It's a bit more complicated than that.
Yeah, there's the delicate balance between also it's hard to get a probe into a country. People might want to replace that, and you get less quality measurements as a result.
So the last point I wanted to make is that exactly that one. Yes, it's easy to smuggle them, smuggle unquote them into conferences, but the RIPE NCC actually has the means, the financial means to import them legally. Yeah. It's just a bit more work, and I personally, with my personal hat on, I would prefer to spend an effort there in getting them, just ship them, and pay the import duty to the ambassadors, rather than go for a second-class solution. Personal opinion.
Okay, thank you.
Is that it? Thank you.
Okay, thank you.